Hi class, I'm just going to initially review the general form of transformation equation, and I'll also remind you that for these notes and other notes I'd like to thank jensenmath.ca. So let's get started. So if you recall from before the break, we began transformations and we're looking at this general form of a transform function. Let's say we call it g of x, and we would say g of x is equal to a times f of k x minus d plus c. So the different parts of this transform function, which are a, k, d, and c, transform different parts of the initial or parent equation. So the c value here, that is responsible for a vertical translation of the graph, of the original graph. So if c is greater than 0, the graph shifts up, and if c is less than 0, the graph shifts down. Now the a value, the information that gives us, it's either a vertical stretch or a vertical compression of the graph of x, f of x, by a factor of a. Or if a is less than 0, we say it's a vertical reflection. That is a reflection over the x-axis, so it flips it. If a is greater than 1 or a is less than -1, it's a vertical stretch. And if it's in between -1 and 1, it's a vertical compression. So a vertical stretch or compression means that the distance from the x-axis of each point of the parent function changes by a factor of a. So we've got a times the original y value. And the vertical reflection, xy, simply becomes x and -y. So it flips it. So those two values, the a and the c, affect the y coordinate. Now for the x coordinate, initially we've got the d value, and the d value translates the original graph to the left or to the right. So if d is greater than 0, the graph shifts right, and if it's less than 0, it shifts left. Okay. And then finally, the k value, if it's greater than 1 or less than -1, it's a horizontal compression by a factor of 1 over k. And if it's in between -1 and 1, it's a horizontal stretch by a factor of 1 over k. And similar to the a value, when k is negative, it's a horizontal reflection over the x-axis. So vertical stretch or compression means that the distance from the y value of each point of the parent function changes by a factor of 1 over x. So you can see here we take the original x and multiply it by, in this case, 1 over k. And similar to the reflection in the y-axis through the x-axis, this is a reflection through the y-axis, so all the original x's become negative. Alright, so I'm going to start a new video for the lesson portion, so you can refer back to this as well. Thanks.